Hello students, in this video we are going to discuss about some of the text-in-text problems based on the boiling point and reactivity towards the nucleophilic addition reaction of aldehyde and ketones. This question is a text-in-text question that is based on boiling point. The question is, arrange the following compounds in the increasing order of their boiling points. Here, some of the compounds are given. We have to arrange them in the increasing order of boiling point. Such type of questions are the most important for the CBSE board examination. You'll be getting usually question on this area. So let us discuss this question. In order to do such type of question, first of all, we have to identify that whether the given compounds are of comparable mass or not. So how we find out whether the molecules are of comparable mass? No need to find out the molecular mass here. Just count the number of carbon and oxygen, because mass of carbon, oxygen and nitrogen you can keep as a similar. You can consider as a quite similar masses, because only small variations are there in the atomic masses of carbon, nitrogen and oxygen. So the mass of carbon, oxygen and nitrogen, you can nearly keep it as similar masses in order to find out the comparable mass. Now just count the number of carbon and oxygen present in these, because hydrogen is not important, because hydrogen have very small mass. So don't compare it. Just find out the number of carbon and oxygen in each. Here 2 carbons are there and 1 oxygen in the first, because 2 carbon 1 oxygen. In the second case you can see there are 2 number of carbon and 1 oxygen. Here also 2 carbon and 1 oxygen. In the case of the third molecule, here also 2 carbon and 1 oxygen. That is 2 carbons are there and 1 oxygen is there. And the last one, that is does not have any oxygen, it have only carbon. And how many numbers of carbon are? 3 carbon. So I told you the mass of carbon is taken as similar to the mass of nitrogen, which is taken similar to the mass of oxygen. So because there is only slight differences in their masses. So when we compare here 2 carbon and 1 oxygen, and here 2 carbon 1 oxygen, 2 carbon 1 oxygen. So these are of comparatively similar masses. Here only 3 carbon is there, but we can take the mass of carbon similar to that of oxygen. So when you see that all these have comparatively similar masses. Now when the given compounds are of comparatively similar masses, then in that case we can apply this sequence, that is hydrocarbon having least boiling point because they are non-polar. Then ether, which is having weakly polar, so they have, in compared to hydrocarbon, ether have greater, but it is only slight differences are there. Then the aldehyde, because aldehyde and ketones which having the carbonyl group, so that is partially negative part of this one and this is partially positive. So because of this there is a dipole-dipole interaction is possible, and when you compare the dipole-dipole interaction as ketones, in ketones 2 alkyl groups are there. So because 2 alkyl groups are there, so there will be more polarity of this bond because of 2 electron releasing groups. So because of this reason we can say that in compared to ketone and aldehyde, when we compare it, ketones have higher boiling point than aldehyde, because in aldehyde only 1 alkyl group is there. In the aldehyde only 1 alkyl group and this is H, but in ketone 2 alkyl groups are there. Therefore this bond will be more polar. So next higher will be the for ketone, but when you compare for alcohol, that can form intermolecular hydrogen bond. Acid can also form intermolecular hydrogen bond. So this is the sequence which you need to remember for finding out for arranging the given compounds in the increasing order of boiling point. But when it have comparable mass, then only apply this sequence. Now look at here. What is given to us? There is one hydrocarbon, because here as these all have comparable mass. So hydrocarbon, that is propane, is given to us. So this have the least, it have the least boiling point when you look at the sequence. So I am keeping this one number, that is the least for having propane. Next you look at here, this is actually water. It is a molecule, that is ether. Let I am giving the number 2 for here. So ether will be having higher boiling point than hydrocarbon, so it will be greater than this. Next we can see here, it is an alcohol and this one is an aldehyde. So when you compare here alcohol and aldehyde, which one has greater boiling point? Alcohol. So if I am giving number 3 to this one and number 4 to this one, so we can say that next will be number 4, that is aldehyde, and then highest is for the alcohol, that is the number 3 is given to this. So this is the right sequence for the boiling point of these molecules. So first you have to find out whether the given compounds are comparable mass. If they are comparatively similar masses, then only you can apply this sequence. It is one of the most important type of question and usually getting the question on this area in the board examination. So you need to practice such type of questions. Next, that is text in text question 12.4. Arrange the following compounds in the increasing order of their reactivity in the nucleophilic addition reactions. So here the two cases are given. We have to arrange the following compounds in the increasing order of their reactivity towards the nucleophilic addition reaction. First, we have to make the structures of each. Now here in the first case, ethanol, that is the structure is here, propanol structure, propanone, that is a ketone, and butanone, that is here. So first we'll be making the structures for these. Then we need to arrange this in the increasing order of their reactivity towards the nucleophilic addition reaction. As we know that when the plus I effect, that is the number of alkyl groups, that is the R, number of alkyl group increases that have a positive index effect, the reactivity decreases. So when you look at here where the number of alkyl groups are more, you can see here there is only one alkyl group. Here also there is one alkyl group, but here there are two alkyl groups are there, and here also two alkyl groups are there. So the number of alkyl group increases, and if the bulkier group is there, we can say that the reactivity decreases. So when you compare these two, that is ethanol and propanol, that is both are aldehyde. So in this case, both have only one alkyl group, but this have bulkier size alkyl group. So when you compare the reactivity of these two, we can say that ethanol is more reactive than the propanol, because there is only one alkyl group and that is a smaller alkyl group, but here there is a bigger alkyl size group. But when you compare the reactivity of propanone and butanone, here both have the two alkyl groups, but here is the bulkier size group. So when the bulkier size group is there, the reactivity decreases. So what will be the correct order for this? As we know that aldehydes are more reactive than the ketone. So here these two are aldehyde. From this, which one is the most reactive? That is, I am giving the number 1 for this, 2 for this, 3 for this, and 4 for this. So we can say that the most reactive will be the number 1. That is aldehyde with a small group. That is a small alkyl group, methyl. Next will be the second, because it have only one alkyl group, but it is bigger than the case of ethanol. Next will be when you compare the third and fourth structure, which one will be more reactive? That is, the third one will be more reactive because here two alkyl groups are there and both are smaller. So the next will be the third one, and the minimum reactivity will be the fourth one because it have two alkyl groups and one of the alkyl group will be bigger in size. So let us see the answer for this. So this is the answer we got here, that is ethanol is the most reactive because it have only one alkyl group and that is a smaller alkyl group. Then second will be propanol because it have one alkyl group, but in compared to ethanol this group, the alkyl group is bigger. Then the propanol, and finally the butanol, which have two alkyl group and both one of the alkyl group is bigger in compared to the propanol. So this is the right answer for this. The next part, that is the second part, the molecules, the compounds which is given here, that is benzaldehyde, paratoluene, paranitrobenzene and acetophenone. Let us make the structure for this one, that is acetophenone. This is acetophenone, that is CH3, C double bond O, and the benzene ring acetophenone. Then this is benzaldehyde, paratoluene, that is if the methyl group is on the para position on the benzaldehyde, then we can say that it is a paratoluene. That means methyl group is at a para position. Then the molecule, that benzaldehyde, is called as paratoluene, and if there is a nitro group at para position to a benzaldehyde, then it is called as paranitrobenzaldehyde. Now we need to compare the reactivity here, as we know that ketones, the ketones are less reactive. So here which one is a ketonic group? That is, this is actually the ketone because other all are aldehyde. So ketones are less reactive than the aldehyde. So from this, which one is the least reactive? That is acetophenone is the least reactive. Now we have to compare the reactivity of the other three. Now look at here, what is common in this? That is CHO and the benzene ring is common for all. So what is the difference here? Here there is one methyl group at para position and here there is one nitro group at para position. So we know that a nitro group is actually electron withdrawing group and the methyl group is a electron donating group. So electron withdrawing group withdraw the electron towards itself. That means the positive charges on the partial positive charge on the carbon will be greater here. But in the case of second, that is paratoluene, here because there is a methyl group, that is an electron donating group, so on the carbon the partial positive charge get decreased. So where the partial positive charge on the carbon is greater, that will be show greater reactivity towards nucleophilic addition. Since in the nitro, that is an electron withdrawing group, the electrons are withdrawn towards the nitro, therefore here the positive charge will be greater, partial positive charge on the carbon will be greater. But here methyl group is there, that is the electron releasing group, it releases the electron. Because of this, the carbon will have more partial negative, it will have greater negatively charged on the carbon. That means positive charge decreases. So when we compare these two, the reactivity of paratoluene, when we compare with benzaldehyde, it will be lesser. So when we compare these two structures, we can say that paratoluene is less reactive than benzaldehyde. But when we compare these two, that is benzaldehyde and paranitroaldehyde, in that case we can say that paranitroaldehyde is more reactive. So which one is the most reactive here? That is paranitrobenzaldehyde. Let I am marking as 1, this is 2, this is 3 and this is 4. So we can say that paranitrobenzaldehyde is the most reactive. Then we can say benzaldehyde because when you compare benzaldehyde and paratoluene is lesser reactive because of methyl group. So the next here is the benzaldehyde, and after that only the number 2 paratoluene comes, and the least reactive will be a ketone, that is acetophenone, that is the number 4 is the least one. So this is the correct order. When we check its answer, that is the answer this is given, that is para-nitrobenzaldehyde is the most reactive, that is this one, then benzaldehyde, then paratoluene, and last is the least reactive is the acetophenone. So this type of questions is usual in the exam, so you need to practice on this. Next question, that is an example question, solved question, textbook 12.3 example question. Would you expect that benzaldehyde to be more reactive or less reactive in nucleophilic addition reaction than propanol? Explain your answer. So we have to compare the reactivity of benzaldehyde with the propanol. Propanol, that is CH3 CH2 CHO, that is propanol, and the benzaldehyde. So we know that the benzaldehyde, that is aromatic aldehyde, is less reactive than the aliphatic aldehyde, that is this is less reactive than the aliphatic aldehyde. So as already we have discussed this in the video session, that in the aromatic aldehyde, because there is a resonance, that is important here, because of the resonance the polarity of the carbonyl group get decreased, that is a partial positive charge on the carbon get reduced, that is due to resonance. So hence we can say that the partial positive charge on that carbon is decreasing, so we can say that the nucleophilic addition reaction it's also decreases. That's why we can say that propanol is more reactive than the benzaldehyde. So better you can make the resonating structures here. So that will be more expressing ways of answering. Make the resonating structure and explain this one. So this is all about the important questions which we have discussed here. In this very important point here, as I already told you, whenever there is a comparative question between the aromatic and aliphatic compounds, like here also it is a comparison between the aromatic, that is benzaldehyde is aromatic, and propanol, that is aliphatic. Both are aldehyde, okay, that is C6H5CHO, that is a aldehyde, and propanol, that is CH3CH2CHO, both are aldehyde. So what is the difference in this? That is, here one is aromatic, that is this is aromatic, and this is aliphatic. So in such case, whenever there is such a question, when there is a comparison between the aromatic and aliphatic type of compound, then always the question, its answer will be relating to its resonance. So that is important here. So if you write the answer here, that is benzaldehyde is less reactive than propanol, because of resonance, that itself will be getting the answer and you'll be getting the mark on this. So that is important point, resonance words here. So better you can make the resonating structure here. So this is all some of the important question we have discussed on the, that is the boiling point question and the question on the reactivity towards the nucleophilic addition reaction. So such type of questions are very important questions and usually getting the question on this area. So this is all about this video. Have a nice day.